Okay, let's get right into it. Nvidia has been on an absolute tear, but their latest moves signal something much, much bigger. We're seeing them transform from just the world's most valuable chip company into the architects of a whole new industrial revolution. And in this explainer, we're going to break down exactly how they're pulling it off.
And really, it all starts with this quote from CEO Jensen Huang. This isn't just about making faster computers anymore. This is about manufacturing an entirely new industry that produces one thing: intelligence. It's a massive, almost audacious ambition, and it completely reframes everything Nvidia is doing right now.
So if you're building a new industry, well, you're going to need new factories. But these factories, Nvidia's factories, they don't roll cars off an assembly line. They're building what they call AI factories. And this one metaphor, it is the key to understanding their entire game plan for 2025 and beyond.
And the difference here is so important. We think of data centers as places that host websites or store our photos, and AI factory is a whole different beast. It has one job and one job only: to generate intelligence. The entire building acts as one single massive computer, all working on creating AI.
Now, to power these new factories, you need a completely new kind of engine. And for Nvidia, that engine is a revolutionary new chip architecture they call Blackwell. This is the huge technological leap that really makes this whole AI factory idea even possible. It all comes down to solving a really fundamental challenge in computing: scaling out. That's connecting a bunch of separate computers together. We've been doing that for years. But what Nvidia cracked with Blackwell is scaling up, making thousands of chips act like one single, unified, unbelievably powerful brain. And as Jensen Huang himself says, this problem is insanely hard.
And the results of solving that problem? They are just staggering. A single Blackwell node today has the same power as an entire top-of-the-line supercomputer from just 2018. That is a 4,000 times performance jump in only 6 years. That kind of progress completely shatters Moore's law.
Okay, so we have the concept and we have the engine. But how do you actually build one of these AI factories? How do you piece together all these chips into one giant, cohesive supercomputer?
Well, it happens in 4 main steps. First, you start with the Blackwell GPU itself, which is already a beast. It's actually 2 powerful chips fused into one. Then you take 72 of these GPUs and connect them with a super high-speed switch and this massive 70-pound spine that's packed with 2 miles of cables. This lets them do something called disaggregation, which basically means the entire rack acts like one giant motherboard. Every GPU can talk to every other GPU instantly. And of course, to stop this thing from literally melting, the whole system has to be liquid-cooled.
And when you look at the numbers for just a single one of these racks, they're just mind-bending. It burns through 120 kilowatts of power. That's enough to run dozens of homes. The bandwidth inside the rack is 130 terabytes a second. To put that in perspective, that's more data than travels across the entire internet. And all of that power delivers 1 exaflop of AI performance. That's 1,000,000 trillion calculations every single second.
Okay, so we've built the factory. The question now is, what does it produce? Well, the answer is physical AI. The intelligence that gets generated in these data centers is designed to go out into the real world, powering robots, self-driving cars, and all kinds of advanced digital agents.
And their approach to robotics is just a brilliant example of this whole end-to-end system. It's really a 3-part process. First, use the AI factory with its GB200 chips to train the main AI model. Second, you use their Omniverse platform to create a virtual world, a digital twin, where that AI can learn and practice in total safety. And finally, you take that trained model and deploy it on a special computer, like the Jetson Thor chip, that goes inside the actual robot.
And a huge part of this is Project GR00T. It's a foundational model built specifically for humanoid robots. Now, why humanoid? It's simple, really. Our world is already built for humans. So if you build robots with our basic shape, you can deploy them in our existing factories, warehouses, and homes without having to re-engineer everything around them.
And this same playbook applies across their whole physical AI ecosystem. You've got the Drive Thor platform for autonomous cars, Isaac for robotics, Omniverse for the simulation, and now a new platform called Cosmos that can generate endless amounts of synthetic data to train these models even faster. You see how it's all connected? It's one big loop.
But here's what might be the most powerful part of their entire strategy. The exact same core Blackwell architecture that powers a multi-billion-dollar AI factory, it scales all the way down to a personal computer sitting on your desk. It's one unified platform from top to bottom.
Just look at this comparison. It's incredible. Back in 2016, Nvidia's top server, the DGX-1, was a 300-pound monster that gave you 1 petaflop of performance. Fast forward to 2025, and the new DGX Spark gives you that same level of performance in a machine that can sit right next to your desk. It's an amazing example of how this incredible power is becoming more accessible.
And if that's not enough, there's the even more powerful DGX Station. Jensen Huang calls it the absolute maximum performance you can possibly get from a standard wall outlet. And get this, a personal workstation like this has enough power to run a 1 trillion parameter AI model. That is way, way bigger than many of the most powerful models we have today.
So the big takeaway is this. Nvidia isn't just selling shovels in a gold rush anymore. They're building the factories, the assembly lines, and the distribution networks for an entirely new industrial age. The hardware is being built, the software is here, the vision is crystal clear. The only question left is, what are we going to create with all of it?